Alright guys, so today we're going to be talking about parabolas in real life. So today's date is 3/15. Go ahead and pause the video and make sure you have this set up in your table of contents. This should be your 6th video for Unit 5. And make sure you add whatever page number you have. Mine's on page 11. Pause the video if you need to. Get us set up in your table of contents. Alright, so parabolas in real life. 3/15/16. Alright, so our objective for today is to talk about what is a parabola in context of a situation. So objective is I can describe the parts of a parabola I'm also going to add another word for the word parts. You'll hear components. Okay, parts of a parabola in context of a real life situation. Okay, so there's a lot of different examples of parabolas. We have arches, roller coasters, bananas, dolphins jumping, people diving into the water. So we're going to look at the components of a parabola that we're most concerned about are the x-intercepts, the y-intercepts, the axis of symmetry, and the vertex. So I want you to understand what those are in relation to the problem, not just say, this is the vertex. I want to know, do you understand what that means? So we're going to look at two problems. One of them, the parabola will be going up and then back down. So we're going to look at a ball being thrown. Okay, so ball in motion. Okay, this is an example of what's called a projectile. Okay, it's like a basketball or a football, something that's being thrown. If you think of the screaming monkey that I threw the other day, it's like a projectile. So a ball in motion, we're going to start off with this guy or girl standing on the top of a building, and his friend is down here on the ground. Okay. All right, and he wants the ball to be thrown. So we're going to say it's a football. And the ball is going to be thrown up and then come back down. So do you see the curve of the motion? All right. So when we're talking about something in motion, all right, we're going to label the different pieces. All right. So our x-intercepts, okay, so let's start with those. X-intercepts. Okay, the characteristic of those is when the height of the object is 0. Okay, meaning it's on the ground. That's a no. On the ground. Okay, so the x-intercept, we would only have one in this case. All right, technically, if the ball continued back this way, we would have another one back here. But the motion doesn't start until here. So the x-intercept is going to be when it lands here. Okay, what is the time here? So it'll be time and then comma 0 as a point. Okay, and t represents time. Okay, most projectile motions are over time. So that's our x-intercepts. Our y-intercept Just like the x-intercept is when the height is 0, our y-intercept is when time is 0. So basically it's position or height at the start. And I'm going to say when t equals 0, because that's when, before it's been thrown. So let's say this guy is 50 feet off the ground. Okay, he's on a 5-story building. So your y-intercept would be right here, okay? And it would be 0, 50, because he is 50 feet off the ground, okay? In this case, let's say maybe it took the ball 15 seconds to get here, so that might be a 15 instead of a t. It depends on how long it takes. And in order to find this, we just plug in 0. In order to find this, we have to factor it and set it equal to 0. Now we're going to talk about the axis of symmetry. So the axis of symmetry is the time when the object changes direction. And what I mean by that is changes from increasing to decreasing or vice versa. So it's going up and then it's going down. Not that the ball is going to be thrown this way and then back towards him. It's changing direction of going up versus down. It could change the other way, all right? But it's the time when that happens, okay? So, again, this is going to be t, and then we don't know what the height is, so, but the height, that leads us to our next one. Okay, I'm going to highlight this axis of symmetry. Okay, so the axis of symmetry is the time when the object changes direction. So the axis of symmetry leads us to the last thing, which is our vertex. Okay. So our vertex, in this case it's a maximum because the ball is going up. It is the maximum or minimum height at the axis of symmetry. Okay, in this case, let's say the ball was thrown up 10 feet before it came back down, so its maximum height would be an additional 10 feet, so it would be 60 feet, yeah? So we need to know whatever our axis of symmetry is, and then it would be 60 feet. So that's an example of a ball being thrown. Sometimes the ball might start down here. Okay, this is just an example of it being up top. So now we're going to do an example of when you might be going down instead of up. So let's look at someone who's diving into the water. Okay, so we've got water, okay, and we could look at even like a dolphin. Let's see if I can draw a dolphin very well. So we've got the fin, nose and the beak. Okay, woo, not too bad. All right, so a dolphin is going to come down and come right back up, and then it's going to jump out of the water. Okay, so in this case, our starting point is, instead of being the ground, it's what's called sea level. Okay, this is called sea level. Okay, when you talk about the elevation of a mountain or a city, it's always in relation to sea level. Okay, so let's go through our x-intercepts first. All right, so we have our x-intercepts. Okay, this is when the dolphin is at the water. Okay, so first x-intercept, second x-intercept. So at sea level in this case. Our y-intercept Okay, it's the position at the start. Okay, so it's the height at the start. So the dolphin is actually at sea level here. So this happens to be the same thing. Okay, so at sea level means that the height, h, is 0. Okay, maybe h would be our f of x. Okay, let's look at the axis of symmetry. Okay, it's where the point where the dolphin is going down and decides it doesn't want to go down anymore, and it comes back up for air. Okay, so stops diving and comes back up for water. So how would we put that in words? That's up to you, as long as you can explain that it goes down as far as it can and then back up. So changes from diving to resurfacing. Okay, instead of going down, it's coming back up. So that's going to be right around here. Okay. And last but not least is our vertex in this case. This is the lowest that the dolphin dove. Okay, so the deepest point that the dolphin dove. Okay, dove down below the sea level. All right. So next week we are going to be doing stomp rockets, which is going to be very similar to our first example. All right. So our first example, instead of starting up here on a 5-story building, we're just going to start on the ground, and we're going to launch a rocket that's going to go up and back down. So we want to be able to analyze and calculate, where did I start? What's the height? That would be my y-intercept. My time would be 0. Okay, and then how long does it take for it to get back down? That's going to be our other x-intercept. When does it actually change directions from increasing to decreasing? And the vertex is, how long does it take for it to get to its maximum height? Will be that axis of symmetry. And then what is the actual maximum height? All right, so we're going to learn how to go from graph to equation and equation to graph, and we want to apply it to real-world context. If you ever plan on being active as like in a sport, whether it's football or soccer, you actually do this already when you're shooting for a goal or throwing the ball to someone. You need to figure out, okay, how hard, how high am I throwing it? We're just adding our vocabulary terms to it.